Microservices, as you may already know, is an architecture pattern that advocates breaking down application functionality into multiple independent small deployment units. I am Sachin and I have compiled a summary of the real-life experiences and challenges my team and I have faced during solution design, development, and implementation of microservices architectures. Microservices are defined by independent deployment units, allowing architecture to break down functionality into multiple small deployment units. Each service can be scaled independently based on demand, and services have clear functional boundaries designed with a single responsibility principle. Microservices align with enterprise goals such as security, fault tolerance, scalability, accessibility, and interoperability. They offer maintenance benefits, making applications straightforward to build, deploy, and maintain. Additionally, they support remote teams, requiring better coordination methods for globally distributed teams. Here are the list of checklists that you should consider while designing microservice architecture pattern. Designing services involves understanding business functions, actors, and use cases comprehensively. Applying solid principles ensures clear application scope, and identifying transaction boundaries is crucial for managing transactions across services. Data duplication is an inevitable reality in microservices, requiring careful design to manage messaging solutions and update challenges. Pub/sub patterns can help but need careful design to avoid overhead, and one-time inserts are easy, but updates require special precautions. Distributed transactions involve having a database per service and implementing the Saga pattern for transaction management. Cross-service transactions span multiple services and databases, requiring careful coordination and management. Effective inter-service communications are achieved through messaging queues for asynchronous service communication, service mesh for secure service-to-service communication, and API communication for synchronous operations. Service registry involves service discovery to find available service instances dynamically and registry implementation using tools like Console or Kubernetes registry services. Service security requires planning a security strategy, implementing service mesh for centralized governance, using identity providers for token-based authentication, and ensuring all inter-service communication is encrypted and authenticated. Integration testing in microservices is challenging due to the difficulty in envisioning and executing test scenarios. Monolithic testing is natural as deployments are consolidated, but microservices require significant collaboration between test and development teams. Performance testing involves evaluating individual service performance to identify bottlenecks, integrated environment testing to understand real-world system behavior under load, and addressing reactive service challenges with specialized testing approaches. Application observability is achieved by collecting automated data from microservices, analyzing insights to generate valuable application insights, monitoring systems to track performance and detect issues proactively, and using insights to enhance application performance. Deployment and scaling involve container deployment, designing services to deploy in any container of choice, using non-container-based data storage for all file operations, and ensuring each service operates independently of its deployment environment. Analytics and reporting face challenges due to data distribution across microservices, making analytics difficult. Implementing data collection strategies like data lakes enables effective analytics and reporting across the distributed system. Microservices may be excessive for simple, small-scale applications where the overhead outweighs the benefits. Teams without experienced architects or sufficient DevOps capabilities may struggle with microservices implementation, especially under tight deadlines. If you enjoyed this video, smash that like button, subscribe, and share it with your fellow tech lovers. Got a question? Drop it below. I reply to every comment. Thanks for watching Tech Talks with Sachin. Stay curious, stay connected.